Well, these are just a few slides I actually put together for the embodied carbon discussion we had that FOI facilitated a couple weeks ago. And it just takes a couple of minutes. There are 4 slides here, and I thought it might be a good primer. But first, I guess a little bit about our company. SLI is a company that's based in Seattle and in Denver. We have a panelized building system where our buildings are actually built in a factory in Tacoma, Washington. As you can sort of see with this imagery, we go from shop drawings, we use Inventor software, which is the same thing, used for spacecraft or aircraft, and design the building to that level. And so we have, imagine, for those of you that have been in the construction industry at all, the idea that you would have shop drawings for your entire building is kind of an interesting thought. But what it allows us to do is it allows us to build our walls and floors and ceilings in a factory and drop them into place. So roughed in, they look like the third photo there under installation. And then to get from the third photo to the last photo, that takes a crew of 5 people, about 4 hours. So this is an incredibly powerful, panelized off-site construction system that means that we can deliver the buildings at a much lower cost than a conventional building in about half the time. And for this crowd, a really significant point is that we have 80% less material in the building. And so therefore 80% less embodied carbon just from the materials. And our system allows us to add different component kits, just like with a car. You might get the cold weather option or, the luxury option in a car. We have the same kind of thing where you can add quality of life options to the units, advanced information systems, and also advanced mechanical systems. And when you pile all of that together, you get a building like this. This is 303 battery. It's in construction right now on 3rd and Battery. We're actually a little delayed with the tunnel that's being removed, coincidentally exactly when we're supposed to be building our building on Battery Street. But you'll see this coming out of the ground towards the end of this year and early next year. And this is the first building of its kind. This is to be built. This is a zero net energy high-rise apartment building. It has 43% lower operating costs than the conventional building. We're building it with no government subsidies at all, and it's 90% affordable and workforce housing. And we're really proud to say this will be the first multi-family building of its kind, even remotely, to meet the Living Building Challenge. So this really, I think, we hope, resets people's expectations about what's possible right now. And one of the key components here is that green, and this is really my big takeaway, is green is, in all its forms, really is efficiency. And efficiency means cost savings. And so the game here is to try to take all of the potential benefits from decarbonizing a project or a building and have a way to get them all the way to the bottom line and not be lost in the supply chain or in the subcontractors. And because that's, at the end of the day, in our mind, that's the final arbiter. Money is the final arbiter here. I think the business case for embodied carbon is really simple. You make more money doing it. There is no other case. If it's not true, no one will do it. And so it's just a matter of understanding how to take sort of the intrinsic value that you're creating by decarbonizing the building and turn it into extra cash. So a cutaway of that building would look like this. We have a whole suite of advanced mechanical systems in this building, and the whole building runs on an artificial intelligence platform that is constantly monitoring and optimizing the building. So we have the ability, just to give you a smattering of what's in here, we have radiant heat in the floors. We have hydronic cooling. We actually use Seattle tap water, which reliably comes out of the tap at 55 degrees to cool the building. That saves us about 5,000 watts of energy per room in this building. We have, it's obviously the whole thing's clad in solar, but we also have the ability to move units of energy, from electricity into heat and then back into power again. And we for example, when you get back from work at the end of a hot day, and your apartment's nice and cool, and you take a hot shower to rinse the day off you, the heat in the water in the shower was the heat that was in your apartment earlier in the day. And we remove that heat through the air conditioning system and put it back into the domestic hot water system to use for showers. We can also, on a day maybe in the winter, when you have heat building up on the south side of the building and cold temperatures on the north side of the building, we can actually extract heat from those sunny units and move them over to the other side of the building. And nobody has to tell the building to do that. It understands what temperatures are going to be that day, and predictively can optimize the use of the building. And then lastly, we have a really, oh, sorry. Go ahead.
Sorry to interrupt. Could you advance the slide? I think folks can't see that systems diagram you're talking to.
Oh gosh, thanks. How about that?
And there was another question. I know you're kind of going through all these amazing features. If you could speak to actually what caused this building to be so lightweight as well as so high performance.
Yeah, so it weighs actually 80% less. So a typical type 1 high rise will come in at about 115 pounds or so as a typical weight per square foot. Our building is 25 pounds per square foot. And the main reason for that is there's no concrete in this building, none. Above the building platform, it's all steel and composite materials. There's no paint, there's no carpet, there's no drywall in the building. So since all of those things, whether they're petroleum-based or wood-based or steel, basically they're all carbon. And so for our ability to, since we're building this thing in a factory, we can absolutely optimize the design of the building to reduce the amount of material. And so really without trying to decarbonize the building, we are. And so that's why the building's so much lighter. And consequently, if you look at the foundation, the concrete foundation of this building, it's comparable to a 5-story conventional building because of the weight loss. Interestingly, from an engineering perspective, the limiting structural factor is wind, not seismic, because the building's so light. It doesn't shake nearly as much as a heavy building. So at any rate, I think that there's a big story here that we tell all the time about the operational carbon savings. This building generates 105% of the energy it uses. And again, we're making money at this today. And I think that's the way I would tie this back into the financial benefit is really, the money sort of looks like this for us. Our building is less expensive to build. It's very high quality. It lasts for 100 years. So a conventional building will have to be replaced at least once in the lifetime of our building. And we have just lower construction costs. So in some of the money we save in construction, we reinvest some of that money into advanced mechanical systems. And that reduces the operating costs. In fact, if you live in one of our buildings, you don't pay a utility bill. The entire lighting load of this building is 350 watts. We charge a green building fee that is about half of what a typical utility bill would be. So our renters are actually saving money every month. So it's cheaper for them to live in this building than the building next door. Even though we're paying and we're charging the same rent, it's saving them money in utilities. And we're picking up an extra $100 or whatever it is a month from a green building fee. So now a conventional building, compared to a conventional building, our revenues are higher and our costs are less. That means the project is just more profitable, and it has a higher net operating income. And that's how these buildings are bought and sold, is based on net operating income. So in the case of 303 Battery, we had a construction loan approved for the project from Goldman Sachs, working with their urban infrastructure group out of New York. And when we got the loan amount, we said, look, I don't think you guys are fully crediting us for the reduction in energy use and the reduction in cost, both upfront and operationally. And so they actually had their engineers look at it. They had the building reassessed, which is not a simple thing for a bank to do, reappraised. And the amount of our loan went up by 15% as a result. So that's 15% less equity we need to build the project. So that is exactly how green building turns into money on a project. And because we're a vertically integrated company, we buy 85% of this building is ordered out of a catalog. And so that catalog is our supply chain. We contract for that supply chain. And just like the idea of electrifying our energy use, because then step 2, you can always clean up the electricity. We have the same sort of philosophy, with respect to how we present this building to the capital markets. And so finally, I guess I just wrap up by saying this is actually a rendering of 303 Battery on the left. And then on the right, you can tell it's not to the same degree of design yet, but this is 901 Madison. This will be the second zero net energy high-rise ever built. And it'll start construction about 8 months after 303 Battery.
Can you advance the slides again?
I'm sorry?
I think you could. Did you talk about the next slide? We're still seeing that section.
Oh gosh, you guys, sorry. Isn't that funny? I must have the wrong. I'm sharing a different window than I thought it was. Sorry about that. So 901 Madison on the right here. Again, very similar design in this case. Both of these are built on single residential lots. The 303 Batteries being built on a 6,400 square foot lot, 112 units. And so everything about these buildings is efficient. And I just want to underscore again, green, it means efficiency, and that means there's money to be had. And from a business perspective, our goal or our challenge is to figure out how to be credited for those efficiencies that we're building. And to do that, we've had to sort of bypass the entire construction industry because that's sort of where the problems lie. And so our feeling is that you're not going to get to the levels that are possible today at a scale without offsite construction. We just don't think it's possible. And so our, again, I think if everybody stays focused on if there is a way where this translates to higher rents or lower operating costs or lower upfront costs, people will do it. Number one. Number two, the biggest lever is the weight of the building. If you watch the weight of the building, that tells you the story of embodied carbon in our minds. Three, We would really like to see a deeper accounting for what we call the carbon shadow of the project, which is really sort of a lifetime carbon analysis. But for example, our building, both of these buildings will be built with 3 crews of 8 people. So you'll never ever have more than 24 people on the site. Conventionally built, it would be about 125 people every day on the site. So because you can't afford to live in downtown Seattle, if you're working on the site, you're probably, commuting a half an hour or more. So and it takes 2 years to build a project like this conventionally. So what's, 100-person commute every workday for 2 years worth. And I think that should be included in the embodied carbon of this project. And if you live in this building, you don't have to own a car. And so, are you not gaining some sort of, if not embodied, intrinsic carbon value by the placement location of the building itself? So we'd like to see this conversation get elevated beyond green concrete. And, thank God we're looking at that, because that's unfortunately where most of the industry is. But we feel like it's our mission to reset expectations of what is possible, and actually what expectations of what is being done right now. And that's our big message, I guess, out to the greater community.
Awesome. That is such a cool project on so many levels, with the affordable housing, living building challenge, the net zero energy, net positive energy, all that is amazing. Thanks for walking us through that. So, residential lends itself to prefab, and that's, I don't know, maybe a third of what we build is residential. So you feel prefab design is kind of like scalable, and obviously within your company, it's very scalable because you have the catalog and all that. And then you're sharing all your secrets, or some of your secrets. So you're obviously hoping it scales, and everybody probably on this call is hoping that this kind of thinking scales, whether it's prefab or traditional, but you've kind of focused on, like, prefab offers opportunities for building weight reduction that standard practice doesn't.
Think about it this way: every building in the world being built right now is a custom tailored project. Every single one.
Yeah.
It doesn't make any sense, And the cool thing, if I showed you other projects that we have that are, low-rise projects or various different configurations, the buildings really don't look at all alike. There's an amazing amount of reconfiguring you can do and aesthetic changes you can make. But the key to this is that it's not modular. It's panelized, right? So we have 44 panels in our catalog, and we can create an infinite number of types of units and size of units in different shapes and sizes of buildings with those panels. And we build the panels so that they meet the kind of the highest common denominator from a code perspective, so that whether we're in New York or San Francisco, Los Angeles, Seattle, or Denver, every panel meets code in every one of those jurisdictions. So that way we're only building one thing, and that's how you start really being able to, clean up your supply chain, start demanding things from your supply chain, that otherwise, there's really no consolidated supply chain in the industry, right? It's kind of a mess. So it's, I think it is step one. You have to consolidate that supply chain, and then step two, you can clean it up. And we're not at step two yet. I will admit, we're now only next year probably looking at how we can further increase the amount of recycled materials and red list items in the building.
So structurally, it seems, structural is something that we focus on often with embodied carbon reductions. Structurally, is it actually metal studs providing most of the structure, or is it wide flange kind of seal shapes?
Yeah, it's so the panels are load bearing up to 8 stories. So we can go to 80 feet without any additional structure. and you know, that's good because with it's still a type 1 building. It's not like a type 5 stick built, you know, kind of 5-on-1 podium. We can actually go 8 stories, not 5. That gives us a big advantage in a lot of locations. And then to go above 8 stories, like the buildings I was talking about here, we actually put an exoskeleton on the outside of the building, and there are no load-bearing walls. In that case, all of the weight is transferred from the floors out to the skin of the building and down. So there are no load-bearing walls in the whole building. It's really interesting.